Quiz. Which twinkles more to your eyes from Earth? A star or a planet? Pick A, star, or B, planet. Hold on to your answer. We'll come back to it shortly. First, let's understand what happens to light before it reaches your eyes. In this video, you learn why stars twinkle, why planets usually don't, and what Earth's atmosphere has to do with both. First, let's understand what happens to light before it reaches your eyes. The light from space enters our atmosphere and bends a little because its speed changes in air. That bending is called refraction. Refraction can shift where a star appears in the sky, especially near the horizon. Twinkling happens when that bending changes rapidly because the air is turbulent, and it's often strongest near the horizon, where the light crosses more atmosphere. So what causes that rapid change? The real twinkle comes from turbulence. The atmosphere has constantly moving pockets of warmer and cooler air with slightly different densities, and they bend light by slightly different amounts. As the air shifts, the light's path changes from moment to moment, so the light doesn't follow one perfectly stable route to your eye. Now think about what your eye actually receives. Imagine your eye is catching a bundle of rays from a star. When more light makes it into your pupil, the star looks brighter. But if the atmosphere nudges some of that light away, less of it makes it into your eye, and the star looks dimmer. A moment later, the path shifts again, and it brightens back up. That flicker is twinkling. Now let's clear up a common misconception. The star usually isn't changing its brightness that fast. The flicker comes from the atmosphere acting like a moving, uneven lens in front of you. If you could observe from above most of Earth's atmosphere, the stars would look far steadier because that moving air lens is mostly gone. So far, the atmosphere refracts light. That refraction changes over time. And because a star looks like a single point, its brightness appears to flicker. Ready to lock it in? Tap the link for study guides and flashcards on this topic, so you can keep learning without missing a beat. Now let's answer the quiz. The correct choice is A, star. Stars twinkle more. Now let's see why planets usually don't. The key difference is size, at least how they appear to us. Stars are so far away that they look like tiny points of light. Planets are much closer, so they look like tiny disks, even if your eyes can't fully resolve the shape. Each little part of that planet disk can still be distorted by the atmosphere. But because the planet is an extended disk, those tiny fluctuations average out, so the total brightness looks much steadier. So stars flicker noticeably because there's basically one tiny source to disturb. Planets look steadier because they're like many tiny sources averaged together. The same idea applies to the sun and moon. They're large disks, so they don't appear to twinkle much. However, atmospheric turbulence still blurs their light. That blur reduces image sharpness and limits how much detail telescopes can resolve. And because the light keeps shifting slightly, measurements of position and brightness become less precise. That's why astronomers care so much about atmospheric turbulence. That's why space telescopes can capture incredibly crisp images. They avoid Earth's atmospheric turbulence. And on Earth, astronomers use tools like adaptive optics to correct for the atmosphere's wobble. Here's a way to picture it. Shine a light through rising warm air, like over a hot drink, and the light pattern jitters. The air is changing the light's path, just like it does to starlight. Here's one situation where this changes. Planets can seem to twinkle more when they're low on the horizon, because their light passes through more atmosphere, where the turbulence is stronger. To recap, stars twinkle because Earth's atmosphere is constantly changing and it bends starlight in slightly different ways each moment. Stars look like tiny points, so the brightness changes are obvious. Planets are tiny disks, so many small fluctuations average out and look steadier. Now that you've watched the video, let's see how much you remember. Head to the link in the description where you'll find Quizlet content made just for you.